Hi, everyone. Welcome to the Digital Science Showcase session on effective collaboration with CERN, Purdue University, and Digital Science. We appreciate you all taking the time to join us today. In this session, we're going to dive into the successful collaboration processes and tools used by our speakers' organizations. We're going to hear from Ashlee Messersmith from Purdue University Graduate School, and then Simon Porter from Digital Science. And we're going to round it out with Patrick Koppenburg with Nikhef, and he's also working with CERN. And then we're going to end with a question and answer period to cover all three presentations. So feel free to type your questions at any time as you think of them into the Ask a Question tab at the bottom of the screen. And we're going to go ahead and kick things off. As I mentioned, we're going to start with Ashlee Messersmith, who is the Thesis and Dissertation Manager at Purdue University. Ashlee manages all the theses and dissertations for the Purdue Graduate School, where she oversees and conducts final approval of all thesis deposits, and she also provides technical support to the graduate students. So, Ashlee, thank you so much for sharing your time and your experiences with us today. I'm going to go ahead and turn it over to you.
Absolutely. Thank you, Marianne, for that great introduction. I want to start by giving a brief overview of our campus. The Purdue main campus is a R1 research institution located in the middle of the Midwestern states of the USA with over 200 majors for undergraduates and over 70 graduate programs. We have approximately 33,000 undergraduate and about almost nearly 11,000 graduate students on our main campus. And Purdue also has many satellite campuses that offer more degree options. Fun fact though, 25 astronauts have graduated from Purdue, so that's pretty cool. The graduate school sponsors Overleaf licenses for all students, faculty, and staff on campuses at Purdue. Although we hadn't quite seen a bigger picture at the time of our adoption of Overleaf, our main goal was to provide this platform to help improve the writing and formatting process. We began seeing an immediate return on investment for that specific goal, but not only were we seeing ROI on the revision process, we were also seeing our Overleaf users using the tool for collaboration, and actually more users were utilizing the tool for collaboration than what we had intended the tool to be used for. We quickly realized that there had been a previous lack of collaboration solutions for our LaTeX users. Not only has Overleaf provided technical LaTeX solutions on Purdue's campus, they've helped to create a better collaboration for the LaTeX authors, both internal and external to our university. We've had many students and faculty collaborate on technical projects, theses, and dissertations, and many use Overleaf for collaboration on journal articles. Our metrics show that in the last month, over 2,600 users at other institutions have collaborated with Purdue using Overleaf. Students collaborate using Overleaf with staff members in my office concerning thesis and dissertation queries. In the past, we'd rely on students to submit the PDF output, and we'd need to comment back via email or using Adobe. And now we're able to help students in real time and know that our recommendations are becoming appropriate actions. Overleaf has helped make the writing process easier, or the thesis writing process easier for students. Students are able to focus more on the research than on the formatting of their thesis, specifically with our new Purdue thesis class file. Overleaf has seriously made LaTeX easy. Native installations of tech programs are perceived as intimidating. That's me. But it's helpful that Overleaf makes the process simple. I've been able to teach Overleaf to our students and have championed the use of it for thesis writing purposes. Utilizing Overleaf has helped reduce the amount of format revisions that we request from our LaTeX authors. With the adoption of Overleaf and improving both LaTeX and Word thesis templates, we've reduced the amount of revisions requested from students from over 2 revisions per student to an average of 0.56 revisions per student. We began measuring deposit statistics in 2016 with the adoption of Overleaf, and since then we've reduced the amount of requested revisions to a thesis document by on average 745 reviews per year. When we were rolling out Overleaf at our institution, we had some resistance from faculty. They weren't keen on utilizing a new collaboration platform with their students. And in fact, many students who submit a thesis or a dissertation would explain that they'd rather use LaTeX instead of Word, but their professor prefers the different collaboration method, the old email files back and forth, multiple versions method. And though we still have those types of complaints, we've witnessed over a 10% increase in the number of students submitting theses and dissertations using LaTeX. We average about 40% of our thesis students submit their manuscripts using LaTeX. All right. Figshare is also used uniquely on our campus for primarily thesis and dissertation submissions. We're not integrated with the libraries with this repository. It's been used for graduate school research only. During our policy revision period in 2018, we wrote a policy that all theses and dissertations submitted to Purdue would be an open access document. This was a major factor for adopting Figshare as our new thesis repository, as we previously had a non-open access friendly repository and an awful workflow to make the submitted thesis an open access document. The transparency with our previous repository was very lacking. It was difficult to track statistics of a published thesis document. Now that we have our shiny new Figshare, we're able to view download statistics for every publication. We've been able to index our repository with Google Scholar, the Network Digital Library, thesesdissertations.org, opendissertations.org, and now are currently researching indexing with open access thesesandissertations.org. Since December of 2018, our theses have been viewed over close to 600,000 times and have been downloaded over 130,000 times. And we've been encouraging students to deposit any data sets alongside their thesis files. With the thesis and data sets that have been deposited to date, we've only used about 95 gigabytes of 150 terabytes. So we still have plenty of storage left. And building upon previous conversations regarding the future of the dissertation, we need to consider repository sustainability as graduate education continues to evolve. And we're actively discussing the future of the dissertation and what dissertation output could look like. We realize that the majority of students will continue to submit a traditional thesis. However, students are beginning to submit multi-author dissertations and dissertations in different media forms. Some examples could include music scores, websites, and 3D models. The tools that we provide to students and other researchers cannot be a barrier to their creativity. Figshare has provided us a platform to continue thesis discussions and how we can support the future of these education decisions. Tools that are pro-open research and collaboration are an important foundation for research. These tools help empower the research community to make research accessible, affordable, and transparent. And as long as we are all still involved in the research community, we need to continue to be champions of open and accessible research and strive to keep the tools available to these individuals so they can achieve their research goals. Thank you.
All right. Thank you so much, Ashlee. That's we really appreciate you sharing all that data and the stats. That was really helpful. So thank you for that. Again, we're going to be getting to the questions at the end of the session after everyone speaks. But please go ahead and type any questions that you have for Ashlee or any of the information that she shared in the Ask a Question tab at the bottom of the screen, and we'll get to those at the end. Next up will be Simon Porter, who is the Director of Innovation at Digital Science. Simon came to Digital Science from the University of Melbourne, where he has worked for the past 15 years in roles spanning the library, research administration, and information technology. So thank you so much for joining us, Simon. I will go ahead and turn it over to you.
Thank you very much. I'll just share my screen. Okay. So today I wanted to take you through the making of this report. So this is a report that I wrote with Daniel earlier this year on using dimensions to look at how COVID-19 is changing research culture. And we did the whole report in using Overleaf, from the very first edits through to integrating the graphs and charts from Jupyter Notebooks, all the way through to the revisions from other people, through to marketing, right through to the finished product. So from start to finish, this is a digital research report that we produced in Overleaf. And in fact, it is now the way we produce all of our digital research reports. So that's really nice to know. So if we have a look at this report, you'll see that it's quite well formatted. It's got a lovely front page, a standard inside page, and in fact, all of our digital science reports will look like this using this template. It's got nice pullouts. It's very easy to read. And you'll notice, because it's a digital science report, it's got lots of data and tables. And so what I will take you through today is the story of how we got that. One fancy thing to show you is that because it's LaTeX and we can embed links and all sorts of things, this graph, in fact, all of the graphs link back to the data in Figshare. So if I click on that, we'll get to the Figshare article. And in fact, the Figshare article links back to the Jupyter Notebook that created it in Gigantum. So if we have a look here, opening up here, here's the notebook that created the actual file itself. Lovely. So the first thing I wanted to talk to you about is the workflow that goes into creating an article like this. So it begins with doing some analysis, maybe in dimensions, creating graphs and charts, and then collaborating with a colleague to work out what sort of story that you might want to tell. So the graphs and charts get put into an Overleaf template, and then the story and the narrative emerges around it. And then we have various people coming in to make edits and revising the text, identifying what the pullouts might be for different markets, right through to doing the proofing and editing and making sure that everything is looking right. So it really is a collaborative process to get a document out the door like this. I thought the best way to take you through what was happening was actually to jump into the track changes of our Overleaf document. So if we have a look here, you'll see that if we went pretty much finished it around the June 20, and if I go all the way back to the beginning, we started in around about the 25th of May. So about a month it took us to do, oh, I'll go back further, 15th of May, I think it was, about 15th of May. So a little over a month to go from a blank document to analysis to forming the ideas to getting the report out the door. So the report began with a template, it looked like this, so a blank template, and it started to be populated around about the 15th of May by me, producing data, figures and tables, and then having put in the analysis that I thought would form a story, we started collaborating, Daniel and I started collaborating around about Saturday the 23rd of May. This is lockdown Saturday, so Saturday is the same as a Friday, the same as a Tuesday, so we worked on that all of Saturday, and then you can see Daniel and I going backwards and forwards up until about, where is it, about, just a little further up. There we go, up until about the 26th of May, where we had the text, we were reasonably comfortable with the narrative, so we started inviting other people into our document to come and read what we had and make comments, but also start thinking about how this document was going to be marketed. So we've got Katie and Alex and Suze coming in thinking about the marketing. We've got Christian coming in to read the content, to make sure it's what we're saying about dimensions is okay. We've got Jürgen from consulting, whole bunch of people coming in and being able to see what we were writing as early as possible. And so now you can see that there are comments being put in by Katie and Bryony and Alex, discussing which pull-out quotes to use, making suggestions for the text. And then we've got also Julia coming into the document, and she's really proofreading the document, also looking at it from a marketing perspective, but also doing things, especially with my tables and charts, making sure I haven't got random sentence case going on in my titles and all sorts of things. So you can see there's a really good backwards and forwards going on there with the team looking through the document. So a whole bunch of changes suggested. Daniel's going in to make the changes. And then you can see there's a backwards and forwards now between Julia and myself, and she's picking up the fact that my tables need changing and my charts need changing. And all of that is very simple. So there you go. That's a nice little vignette, if you like, on a whole bunch of people coming together to work on the document to create what it looks like here. So how did it start? It started with a template like this and some analysis in a Jupyter Notebook. And so what I thought I'd do is take you through how easy it is to start putting your analysis straight from your Jupyter Notebook, so your charts and your tables, into your Overleaf document. And the reason that's a really important thing, and a really something that saves a lot of time, is that once you've made that connection, your charts and tables become part of the collaborative process. So it isn't the case that you're producing a document right at the end and you finished all the analysis, you put the tables in, and now it's over to do the write-up. You can actually do the write-up and the creation of tables and charts in an iterative fashion. And the reason that's possible is because the overhead of recreating those charts, recreating those tables is quite low, because all you need to do is update your Jupyter Notebook scripts and rerun those tables, And the process of inserting them into your Overleaf template is really quite straightforward. In fact, you don't need to do any further work once you've made the connection. So what I thought I'd do is take you through an easy example of how that happens. So here's a blank template. So here's what we start with any given digital science research report. And you'll notice that it's got all of the branding layout and layout suggestions inside it. And here is a Jupyter Notebook. So this is just an example Jupyter Notebook that I prepared. It's got my standard libraries that I might want to use. And in fact, it's got another library from Gigantum called Gigaleaf. And this little library is going to do the integration for me between Overleaf and Gigantum using the Git bridge between the two. So if I just run that, it's going to ask me for my project in Overleaf. So I'll go and get the address for that. And lock that in. And carefully type in my password. And now it's making that link between Overleaf and my Gigantum notebook and copying the files across. So it might take a few seconds to do that. There we go. And now I've got that link across. I can create some data science. So I've got some data. I'll make it into a graph. I'm going to create the graph, save it to a local directory, use my Gigaleaf module to link that image with my Overleaf project, and then synchronize it. So here's my graph now. This is a graph of the number of articles on COVID-19 that are going into Dimensions on a daily basis. You'll see it's about 1,000, which is pretty amazing. And if we go back, oops, got to get something from here. We insert that line into my Overleaf template. And I do one more thing because it's using subfiles. I'll put some other setup in my preamble. And I'll recompile that. We should see the image come up. And you can see over here that my template now has a Gigantum folder. It's got the data in here with the image that I've just put in. It's also got some metadata. So one of the nice things is that you can actually track, not only did this image come from this Jupyter Notebook, it actually came from a particular revision of the notebook because the notebooks inside Gigantum are actually track changed as well. So that's quite a nice little feature. Whilst that's compiling, is there anything else I can tell you about this notebook? So that's using the Git bridge in Overleaf and using the function from Gigaleaf module from Gigantum. But if you're just using Jupyter Notebooks more generally, you can just use the Git functionality to integrate files that you need. So this is an example here of using Git inside Python, inside a notebook. You supply it with your username and password. And then really all you're doing is exactly the same way as you're synchronizing your project, creating your file, and then you're just pushing it and pulling it across. So I reckon it's probably finished by now. So we can see here, and here's my image. So I just really wanted to take you through quickly some of the things that we did, both from a workflow perspective, joining up the creating of the data, the writing of the article, through to the proofreading and the suggestions and identifying the pullouts, and how that can all be done in Overleaf from start to finish. And that's a real improvement on our older processes where each of those stages were far more linear. So the data would be prepared, it would be perhaps copied and pasted into a Word document, a text would be written, and then it would be sent for typesetting. Then someone would come back and say, oh, can you change that image from blue to green or change the colors? And all of those things happening quite slowly. And so with this setup, we can actually decrease the time it takes between those steps and actually have those things happen iteratively. For instance, we saw in the track changes before comments between Julia and myself. Can you change the title of that graph to be sentence case, or can you make it a different color? And in fact, all you need to do that is to go back to your notebook and make the changes that you want in your charts. And then that will come through to the Overleaf document. In the interests of time, I won't resynchronize the documents, but you would see now that all I needed to do to make that chart from blue to green was to change the Jupyter Notebook. So I think I might see if that compiles. If it doesn't, whilst it's doing that, I will hand back to Marianne.
Excellent. Yeah, thank you. Oh yeah, screen now. Very nice. All right, thanks so much, Simon. We appreciate you showing us that workflow. That was really interesting, useful to see. Anyone who's listening, if you have any questions for Simon, again, please go ahead and type them into the Ask a Question tab, and we will get to those at the end of the session. But we appreciate it, Simon. All right, and our last speaker for this session is going to be Patrick Koppenburg with Nikhef, the Dutch National Institute for Subatomic Physics. He is an article physicist working on the Lhcp experiment at CERN. So Patrick, thanks so much again for you taking the time to share your experiences with us. I will go ahead and turn it over to you.
Thank you. Trying to share my screen and moving there. So in principle, now you should see a picture of Geneva.
Yep.
Yeah, good. So I'm presently at CERN near Geneva, and I'm working on the Large Hadron Collider that you see depicted there. And we are a somewhat special user of Overleaf in the sense that we're writing a lot of papers that have a lot of authors, and this has actually helped us a lot. So I'm working on the Lhcp experiment. That is the experiment that is next to Geneva Airport. That you see, that's this white band that you see in the middle of the picture. There are 3 other experiments that are actually bigger in terms of experimental size and also number of people working on them, but the procedures are all the same. We are about 1,000 people, actually 1,300 members now of the Lhcp collaboration from 83 institutions from 19 countries. So it's a big international effort with universities from all over the place collaborating to analyze the data that comes out of this detector that you see in the back, and to actually build this detector, because presently what we're doing is to replace this detector by an upgraded version. So if you want to have an idea, this is we photoshopped some part of the collaboration in front of it, but it's about 20 meters long from one side to the end, and it's located 100 meters underground because that's where the accelerator is. So we're producing scientific papers. So our last preprint that you can find on arXiv at the link that is provided here above has 977 authors. We have this tradition in particle physics that everybody contributes to build the detector, and since all our physics uses the detector, everybody gets to sign the paper. So everybody also gets to comment on the paper. And this is a process that needs to be managed somehow. We are producing many papers, kind of an average of 50 per year, and we started data taking in 2010. So we now reached the 500 papers bar, which we're very proud of. But of course, if you have 500 publications and 1,000 authors, that's a lot of potential comments to deal with. And the only way of doing that efficiently is to have a quite strict procedure. So our procedure looks like this. You're probably not going to be able to read everything in that Gantt chart, and on top of that, it's full of LHCb specific jargon. But The important point is that it's a quite strict procedure with fixed deadlines that cannot be extended by very much, and also cannot be shortened. So if the collaboration gets 2 weeks to read a paper, that's 2 weeks and no more and no less. And then there is a committee of 11 people who had the pleasure to chair until a few months ago, who read all the papers or share the reading of all the papers among them, and make sure that it complies with our our template and our LHCb specific style. And then at the very end, the editorial board chair has the final word and gives the green light for submission to archive, and then submission to the journal. So at this point, then it's too late for anyone in the collaboration to comment. We then assume that everybody who wanted to change something in the paper has had plenty of opportunity to do so. So actually, Overleaf has been very helpful in that. That's one of the things I introduced while I was chair of the editorial board, because it was new at CERN. We've been using LaTeX for decades at CERN. You know that it was partly also developed at CERN. Michael Goossens, who wrote the LaTeX companion, was actually a CERN physicist who then went into CERN IT. So there's a lot of knowledge on LaTeX there, and nobody would dare using something else to write a scientific paper. But then the way of collaborating together in big collaborations, this has changed a lot over the last decades, and in particular for this last stage of the process, which is when the editorial board goes over the paper and comments on it. We're using the comment feature a lot, and this saves a lot of time compared to the traditional way of submitting comments via email or via some document server platform as provided by CERN, and so we're getting into interesting discussions actually on the physics of the paper in the comment section. And you see here, this was a paper that we submitted earlier this year, one of our benchmark analyses with exciting results that may hint at something not understood in particle physics. So that's really all I wanted to say here. Just to tell you that once you're collaborating with more than a handful of people, then you should really put people in charge. Define procedures and deadlines before you start writing the paper, and use collaborative tools in order to help everybody commenting and avoid sending files around per email. That's it from me.
Awesome. All right. Well, thank you so much, Patrick. That was great. So, all right, now we are going to open up the question and answer period. So I will go ahead and take any of your questions that you have. If you'd like to add them into the Ask a Question section, we can do that. Let's see if we got one on here. All right, so a question for Ashlee. Let's start with yours, Ashlee. So when you, did you get pushbacks from students to use the templates and the repository? Was it difficult for them? How did that go?
So if you were talking about the LaTeX template, the Purdue thesis template that we've got, no, we actually didn't have any pushback. Occasionally we would have some students who try to make their own guide for thesis formatting requirements, but overall, since we require our thesis, each thesis to look basically the same, with the type of front matter and whatnot, they were very happy that we could provide them that type of service, because especially with the University Griffin is not available for students to use, and that was very difficult for them to add and make it look right on their own. So no, not really any pushback from the students. They're more grateful than anything. And then Marianne, what was the repository question?
yeah, any confusion or any pushback on that as well? Or is
we didn't have any confusion really. So we have an all automated system with our thesis deposits. So basically, the students have to get electronic signatures on a thesis form, and then once their committee signs off on that form, then they get an email with instructions on how to deposit. So we actually don't provide a lot of external information to these students. It's all internal, and it all goes by email. So we try our best not to put things out on the internet, especially because we did use ProQuest previous. And the link to ProQuest was just out there, and then students were depositing their thesis to ProQuest before, they even got any of their signatures from their committee. So they were depositing before they were getting approved. So we've tried to definitely reel that in. We haven't really had any pushback with the open access theses either. Everything that we've had was just, oh, thanks for doing this for us. Now, of course, the students are still able to protect their thesis by confidentiality and embargoes and whatnot. So, but we just try to limit how much we can, protect them by. So yeah.
Sure, that makes sense. All right, cool. A question for Simon. Did you create that report template on your own, and are you planning on using it in the future? Can you use it in the future for future reports?
So absolutely, I can use it for future reports. I created an original template on my own using my somewhat limited LaTeX skills. So there was lots of, in the original template, there was lots of spaghetti LaTeX code doing things that I could get it to do, but it served as a nice template. And in fact, it became an exemplar that the Overleaf team used to create a report on how things are working at CERN. So that was the digital science report came from that. Once we worked out that it was actually quite a successful way of doing things, we had someone in the Overleaf team, Paul, actually work on the template and create a very nice, very usable template. And he didn't work with me on that. He actually worked with the marketing and communications team. So he actually collaborated with the communications team, and they made sure that the Overleaf template looked exactly the same as the pre-existing templates. And so it isn't just a template that is to be used by technical users. Just like the thesis templates, it's designed to be used by everyday users, which is quite exciting. So we've probably produced, I think, 3 or 4 reports now using that template, and we'll be planning on using it going forward now.
Mm-hmm. That actually goes in well with another question that we got for you, which is, did everybody need to know LaTeX? Obviously, you have the folks in the marketing team and promotions and things like that are actually working in that template. Was that difficult for them because it is more of a LaTeX template?
No, because once at the point where they're invited to contribute to the document, the text has been written, the tables have been written. So really, when they're engaging with the document, they're engaging with it in terms of reading the text. So they've got the compiled version that they can read through, but they've also got the rich text format view that they can flick to. So Overleaf's quite friendly in that you don't have to be comfortable reading code to be able to engage with the document. So you saw during when I went through the track changes, they were real people making real edits to the document, and all of those people except for Daniel and myself don't have any LaTeX experience.
Okay, great. All right, thanks. So Patrick, I have a question for you. What has been the feedback or reaction from the researchers there at CERN when it comes to having this process, very strict process set up? I mean, was it difficult to roll out to them or get engagement from the researchers there with that?
No, I think they were used to such processes because the senior people who joined Lhcb at the very beginning, that was 10 years ago, they were coming from other experiments that had similar processes. So these things evolved and became more strict as the size of the collaborations increased, but there were also some horror stories that circulated about the Lhcp experiment in the 90s that did have much more relaxed procedures, essentially searching for everybody to agree with a paper until they could go to the next step, and that this delayed science in the end. So it's to prevent these kind of things that then the next generation of experiments from 10 years ago started implementing stricter procedures, and we're just making these we are refining them constantly, actually.
Mm. Yeah, so that kind of goes along with another question, which is, what is the most problematic aspect of these large collaborations, would you say, and what was the best fix for it? What was it you struggle with the most?
Actually, the most problematic, seen from the point of view of the editorial board, is to get the people to actually engage with the papers, because when you start to have 50 publications, which are then your own publications per year, you're beyond the threshold of being able to read them all. So you're signing papers that you haven't really read, and so we need to constantly make sure that there's a certain number of people who are forced to engage with the paper and who are not necessarily expert on that particular analysis.
Mm-hmm.
And so we have at some point we had to appoint 6 of the 83 institutions for every paper to ask them to send questions. At the beginning of the experiment, you have a lot of enthusiasm for the science that comes out, but after paper number 200, it becomes, yeah, okay, get another paper.
That makes sense. All right. Well, I think that is all the questions that we have for today. If anybody else has anything to ask, go ahead and do add it into the Ask a Question, and we will always, we can answer it afterwards. And you can go in there and take a look at any of the answers. As far as this session, there is going to be a recording of the session available by using the session link that you used to get in here today, and it will take you to the recording. And we'll also be putting all the recordings onto the Digital Science YouTube channel. So you can go in and see any of the sessions for the Global Showcase there. I wanted to thank again Ashlee, Simon, and Patrick. Thank you all for taking the time to share your experiences with us and be here with us today. And all of you in the audience who took the time to join us, thank you to you as well. These sessions on Crowdcast are now finished for today, but if you want to carry on the conversation, you can head over to the networking and social session in Remo, which is going to start right after we finish here. And you'll be able to meet the product teams, as well as you can network with each other. And I've been told that there's a virtual photo booth that you can use. And there's also going to be a competition tonight to win some digital science swag by connecting table names. So definitely take advantage of that. And the link to join that networking Remo network is going to be below and in the chat as well. You'll be able to join there. And that is all we have for today's session. So thank you again to everyone, and have a great day.
Thank you.
Thank you.
Bye.
Thank you.